Hi, this is Mrs. Kidman, and in this video, we're going to be discussing how we can use average rate of change to answer word problems and figure out what the average rate of change is in those situations. So first, let's take a look at this average rate of change problem. This definition of average rate of change, excuse me. How much average rate of change is how much a function has changed per unit on average over that interval. Now, we've kind of discussed this in the last two videos about how we can do that on a graph and how we can do it in an equation. But now let's look at what we can do with it in a word problem. So let's first take a look at this first one. So Vera uploaded a funny video to a Fails website. VT shows the number of views over the first 20 hours it was online. When did the number of views increase the fastest? Was it from 0 to 5 hours, from 5 to 10 hours, from 10 to 20 hours, or all the intervals were the same? So let's start by calculating what is our average rate of change here. Well, let's look at this first one. So we weren't given a graph here, we weren't given an equation, but we were given some data. So our points are, this is our X value and this is our Y value. So we want to calculate how many views, like what was the average rate of views in the first 5 hours. So we can do that. Remember that the average rate of change is our change in Y over our change in X. And so that means if I change by going up 70 here, I'm going to divide that by the change here, which was up 5. So from 0 to 5 hours, our average rate of change is going to be 70 over 5. And 70 over 5 is going to simplify into 14. So that means there were 14 views per hour. Okay, that's not a bad rate. That's quite a bit. Now, what about from 5 to 10 hours? Let's take a look at that. So from 5 to 10 hours, our X value increased by 5, and our Y value increased by 110. So we already can see that these increased the same number, but it increased a lot more here. So I'm guessing that they probably had more views per hour from 5 to 10 than they did from 0 to 5. Let's take a look. So our average rate of change, remember, is going to be our change in Y, which was 110, over our change in X. And 110 divided by 5 is 22 views per hour. So that is substantially more. That is, you're having at least 8 views more per hour from hours 5 to 10 than we did from 0 to 5. Now, the last part that we want to look at is how many views we have not from 15 to 20, but from 10 to 20. So from 10 to 20, our X changed by an increase of 10. From 180 to 500 as well. And that 180 to 500 is an increase of 320. So let's see what the average rate of change is there. So the average rate of change from 10 to 20 was 320 divided by 10. And that's 32 views per hour. That is so much more. That's 10 more views per hour than the 5 to 10. And that's going to be 18 more views per hour than the 0 to 5. So the longer it's been on, the higher the average rate of change is. And that's kind of what we're looking at there. Now let's take a look at one other problem. This next one has a table and a graph that shows the population of 2 species of fish introduced into a lake. And we want to compare the population by calculating and interpreting the average rate of change from year 0 to year 4. So we're trying to figure out from here at year 0 to here at year 4, what was our average rate of change there? What is that? And so we have a couple different ways we can do it here. We can use our graph if we want to, but it's not going to be as accurate. We also can use our data, and that's what we want to use here is we want to use our data. So our data that's important here is this 0.0100 and 428. So our X change, so our change in X here, is going to be, it increased by 4. And then our change in Y is that it increased by 328. So as we're calculating this average rate of change, our average rate of change here is going to be our change in Y, which is 328, over our change in X, which is 4. And as we simplify that 328 divided by 4, we end up getting 82. Now, the biggest thing with average rate of change is figuring out 82 what's. So the average rate of change, what are we comparing? So what really is happening is our population is increasing. That population of those species of fish increases 82 fish per year. Or 82 fish per year. So our average rate of change is 82 fish per year. That's kind of awesome, right? Increasing. So with these two examples, you've seen how just given 2 points, we can calculate that average rate of change. I want you to use that information to answer this bottom question down here. So we are now looking at, instead of 0 to 4, we are looking at year 4 to 8. So using the data up above, compare the population by calculating and interpreting the average rate of change from 4 to 8. So we're looking from 4 all the way up to 8. What is that average rate of change? So go ahead and use our graph, use our data, and pause the video and take a second to calculate and compare what those 2 points are and find that average rate of change. When you finish, unpause the video and we will discuss what that average rate of change is and how we get it and what it means. Okay, hopefully you've had a chance to go over how to calculate this average rate of change on your own. So we were comparing the rates by looking at the average rate of change from year 4 to year 8. So I circled up above year 4 and year 8, and I found what is the difference between my x values. So my change in x values from 4 to 8 is adding 4. And then my change in y values, so going from year 4 to year 8, we increased 328. So remember, our average rate of change is going to be the change in y over the change in x. And so as we're calculating this, we want to write our change in y, which is 328, over our change in x, which is 4. And that 328 divided by 4 is 82. Now that 82 needs to have a label on it because this is a story problem, a word problem. And our measurements that we're looking at is what is the population of these two species of fish every year. And so our average rate of change is 82 fish per year. So every year that we go up, on average, the fish increase by 82. And it's kind of an interesting thing because in our previous problem, we got the same thing. And so it's cool to see that like this function here, that average rate of change is pretty consistent, which says a lot about our species of fish there, that they're reproducing and in a very similar rate every year. So that is average rate of change when we are given a word problem or when we're given data points that aren't given in a graph or they're kind of in between on our graph and we're not quite given the function. So this is how we can do it when we're just given a table of values to find that average rate of change. If you have questions about how to find the average rate of change on a graph, or when you are given a function and the interval, feel free to check out the previous videos discussing that. Thanks.